In this video, we will introduce custom entrance controls. You can modify the built-in behavior of the material flow objects with an entrance control in which you can program the actions that you want to execute. In the previous videos, we've already seen that most objects have a control tab in their dialog where the user can define his own controls. These controls are created using the easy-to-use SimTalk scripting language, which is fully integrated into plant simulation. The entrance control is called as soon as an MU intends to enter the object. In an example model, we will change the processing time of a station in the entrance control, depending on the name of the part that is processed. To do so, we will place a source, a station, a conveyor, and a drain. Then we create a new data table and drag and drop it to the source. The reason for doing this is that we want to parameterize the source. In this way, we can let the source produce parts according to the parameters we will enter in the data table. Now we open the data table and drag and drop our parts from the class library into the first two rows. We then name the parts A and B. In this example, we want to change the processing time of a station depending on the name of the part in the entrance control. This could be also achieved by using a type-dependent distribution. However, in the entrance control, we can do more precise adjustments. To do so, we switch to the Controls tab. As you can see, the entrance control is empty. If we now click on the three dots, we can create a new entrance control or select an existing one. We will create a new one. As you can see, the entrance control will be named automatically and gets the name on entrance. The self in front of the name of the entrance control denotes that the entrance control is a user-defined attribute of the station. If we change to the user-defined tab of the station, we will see that the entrance control is placed here. If we now double-click on the name of the entrance control, we can see its name and data type. If we close the dialog and double-click on the value field, the entrance control will open. We could also open the method from the context menu of the object. To do so, we open the context menu of the station and click on Controls. Here we can select Entrance and open the entrance control in this way. Typically, you should create the entrance control as a user-defined attribute, but if you want to use the same entrance control for multiple stations, you can insert a method object into the frame. In this way, you can create one entrance control and use it on multiple stations. To showcase this, we insert a method object and rename it to Custom Entrance Control. Now we insert two more stations. We then open the dialogues of the station, and instead of creating a new entrance control, select the one we created. In this way, both stations will use the same entrance control. However, keep in mind that if you now delete the stations, you need to delete the method object separately, since the method object is not an user-defined attribute of the stations. We now start to write our code. What we basically want is that we first check the name of the part. If the name is equal to A, we want to set the processing time of the station to 20 seconds. If the name is not A, we want to set the processing time to 15 seconds. We can achieve this if-then statements by using control structures. Plant simulation provides us a template of control structures that we can simply use. In the Edit ribbon, we can click on Control Structures and choose an appropriate one. In our case, we need an if-else block. Now the tooltip shows us additional information. After the if, we need to insert a Boolean expression. In this case, we want to query the name of the part. So we need to address the part that is on the station. If we want to access an MU that is on a material flow object, we can always use an at. So the at will correspond to the part that is on the station. If we want to access attributes of objects, we use the dot. After we inserted the at and the dot, we need to find out how we can access the attribute name of the part. Therefore, we can open the dialog of the part from the class library. Then we click on the question mark and then on the field name. Here we can now see the SymTalk reference for the name of a part. Now we switch back to our method and type name after the dot. Keep in mind that SymTalk is not case sensitive, so you can either use uppercase or lowercase letters. We will now check if the name is A. To do so, we use the equal sign. Since name is of data type string, we need to use quotes after the equal sign. Now the first line is finished. The second line denotes what plant simulation should do if the condition is met. Here we want to change the processing time of the station. If we want to access the material flow object or the control that called a method, we use the question mark. So in our case, since the control is called from the station, question mark is designated to the station. So we insert a question mark. However, we do not know how to access the processing time. Therefore, we open the dialog of the station. Here we again click on the question mark and then on the field processing time. Here we see that processing time is proc time in SymTalk. We then switch back to the method and set the processing time of the station to 20 seconds. For the assignment operation, we use the equal sign. In the else branch, we enter what the station should do if the condition is not met. Here we enter that the processing time should be set to 15 seconds. For historical reasons, plant simulation also supports a colon in combination with the equal sign as an assignment operation. Now we want to debug the entrance control. To do so, we set a breakpoint into the entrance control. You can set a breakpoint by either using the F9 shortcut or right-clicking and then clicking on Class Breakpoint. We use the breakpoint to pause the simulation whenever the breakpoint in the entrance control is reached. After inserting the breakpoint, we need to save our changes. We can do this in the Edit ribbon by clicking on Apply Changes or pressing F7 as shown. Now we need to turn on the checkbox Before Actions. For the station, the setting Before Actions sets if the entrance control is called before the standard actions are executed when the part enters the object. Standard actions are, for example, evaluating the processing time or the setup time. Since we want to make changes to the processing time, we want them to apply before the standard actions, so that the processing time is overwritten. We start the simulation now, and as you can see, a debugger window will open as soon as the part enters the station. In the debugger, we can get additional information from the tabs at the bottom. Here we switch to the Anonymous Identifiers tab. Anonymous identifiers make using a method more flexible and independent of its context. You can insert them into different models without having to modify its source code. Normally, the name of a control you programmed in a method does not change in your model. The path to the method changes from model to model, though. If a control requires the current path, you can query it by using anonymous identifiers. To learn more about anonymous identifiers, you can have a look into the help. As you can see, at and question mark are also anonymous identifiers that we already have used. There are several more anonymous identifiers, as you can see. Additionally, you can see what the values of the anonymous identifiers are. So as expected, @ correspond to the MU that is on the station, and question mark corresponds to the station. In the debugger, we can now, for instance, hover over @ and can see to which value it corresponds. If we hover over name, we can see to which value name corresponds. The same applies for question mark and the processing time. The debugger helps us to debug methods and controls. To do so, it provides a couple of commands. The first command is step over, which corresponds to the shortcut F10. It executes the source code of the method one line at a time. The second one is the command step into which corresponds to the shortcut F11. It executes one line of the debugged method at a time. If the line happens to call other methods, Plant Simulation will load this method into the method debugger as well. The third one is the command step out, which corresponds to the shortcut Shift and F11. It finishes executing the current method and steps out of it. It then stops at the next statement of the calling method. The fourth one is the command continue, which corresponds to the shortcut F5. It continues executing the active method. By using these different commands, you can debug the method. For now, we will just use the step over command. If we click it one time, it will jump in the corresponding branch of the if-else block. Since the name of the first part is A, it will jump into the first branch. If we now hover over the processing time, we can see that it is 10 seconds. If we click it again, the processing time will be set to 20 seconds and it will jump to the end of the method. If we then click it again, the simulation will continue to run and stop when the entrance control is reached again. If we now click again on Step Over, this time the debugger will jump into the second branch, since the name of the part is B. If we hover over the processing time, we can see that it is set to 20 seconds. If we click again, the processing time is set to 15 seconds. Now we reset the simulation. Now we will shortly recap again on anonymous identifiers. So the basic concept is that we can use them independently from the context. If we would have used, for instance, a parallel station, then still question mark would correspond to the object or the control that called the method, and @ to the MU that is on the object. So we could basically copy and paste this entrance control to the entrance control of another object, and it will work. You might ask yourself now, in which case this would not be possible. We want to demonstrate this in this model. In the entrance control, we now use the relative path of the station instead of the question mark by dragging and dropping it into the entrance control. We then start our simulation. You will see that the simulation runs perfectly. Now let's assume that we need to do changes to the name of the station. So we change the name of the station. As soon as you start the simulation, an error occurs since the name of the station changed. As you can see, if we would have used the question mark instead of the relative path, question mark would be still corresponding to the station, even though we have changed the name of the station. When you have length-oriented objects, like the conveyor, it is also important to be aware of front and rear triggered entrance controls. We open the dialog of the conveyor, and then we switch to the Controls tab. Here we can see that we can choose that the entrance control is either front or rear triggered. If we want the entrance control or other controls to be triggered when the front of the part enters the object, we set the checkbox front. If we want the control to be triggered when the rear of the part has entered the object, we set it to rear. If you want, you can also activate both. Then the entrance control is triggered 2 times when the front and the rear of the part has entered. We can also see that the conveyor has a backwards entrance control and a backwards exit control. The backwards entrance control is triggered when the MU enters the conveyor via their exit. The backwards exit control is triggered when the MU exits the conveyor via their entrance. However, we need to first set the conveyor to backwards in the Attributes tab if we want to use this controls. As always, you can get further help by using the question mark in the title bar or having a look into the help. This concludes our video about entrance controls.